Draw yourself another line, a second line that intersects your first somewhere. So these two lines should intersect each other. Make it very clear where they intersect each other. Make it a nice point where that point of intersection is. And then here you go. Make a third line that goes through that point. So basically at the end of this, you have 3 lines that go through the same point. Those 3 lines are concurrent. That's what I mean by concurrent lines. 3. It could be more. I wrote or more, but usually we're going to stick with 3. 3 lines that all meet at the same point. Right? They are called concurrent. I want to use that vocabulary term. I don't want you to tell me 3 lines that intersect at a point. Say concurrent lines. All right, concurrent. They all meet at the same point. And mathematicians, hey, they're pretty clever. They actually put a name to that point where they all intersect. It's called the point of concurrency. Okay, I know they really probably thought long and hard about that name, huh? So lines are concurrent when they all meet at the same point, and that point is called the point of concurrency. Any issues? 2 new vocabulary terms down already, and we haven't even hit 2 minutes yet. Next box. Can you guys please make a circle, please, inside this box? I don't care what the circle looks like or how big it is. Just draw a circle for me. All right. Inside that circle is going to go a triangle, but with a requirement. The vertices of the triangle must touch each side. The vertices of the triangle must touch the circle. All 3 vertices. So, hey, this right here won't cut it. That's not what I'm looking for. The vertices must touch it. And guys, you can freehand the circle, please. Freehand the circle because it's wasting time. This is what I got to cut out of this class. Okay, so make sure each vertex is touching the circle. The circle, not the triangle. The circle, notice it's on the outside of the triangle. If anything's on the outside of a figure, we say it's circumscribed. Circumscribed. All right, watch your mouth when you let that roll off the tongue. All right, circumscribed. Everybody good? When the circle or anything is on the outside, it's called circumscribed. All right, let's flip the script now. Let's flip it. Everyone draw yourself a triangle now in the third box. And let's put a circle inside, but hey, the circle better touch all 3 sides. Okay, the circle's got to touch all 3 sides inside. There it is. When it goes inside, now it's called inscribed. Sounds like the word inside, right? So if it's inscribed, that tells me the figure is inside. When it's circumscribed, that tells me the figure is outside. Like, could I change it up and say the triangle is what? In this diagram, the triangle is? Oh, the triangle's not circumscribed. The circle is. The triangle is inscribed. Good? And now here, the triangle is what? No. The triangle's on the outside, so that means it's circumscribed. Okay, everybody good? If it's inside, inscribed, on the outside, circumscribed. All good. Questions? Because those vocabulary terms are going to come up here again in a second. All right, let's get to our big topic of the day. We're going to find out that in a triangle, there are three lines that are going to be concurrent. 3 lines that are going to be concurrent. Instead of me just giving it to you, we're going to do a little project, group project now. First thing you need to do in your group, go ahead and graph triangle ABC for me. And please label the vertices and connect the vertices to form a triangle. I still don't like that. All right, I'm going to put each group to a task right now. And all you do is your task only. Don't do another groups, please. All right, so when I refer to group 1, that's going to be this whole lane of 2 groups right here. All right, that's group 1. Group 2 is going to be this whole lane right here. So a lot of heads here thinking. And group 3 is going to be the back 2. Okay, here's the first job. You're going to find the midpoint of your respective side. So group 1, you're going to find what the midpoint of AC is. Group 2, only find the midpoint of BC. And group 3, only find the midpoint of AB. Oh, what's the midpoint formula? Not my job. I'll meet back in about 2 minutes. Go ahead. Find the midpoint of each side.
Formula? Thanks. Something divided by 2.
I can't tell X or Y.
X2 divided by 6. I think it's minus and plus.
Minus is
Please, even though it wasn't your responsibility, make sure it gets put down in your notes. And then we're going to graph it after each group tells us the correct midpoint. All right, so make sure it gets down in your notes. And we're going to graph it. Group 1, what was the midpoint of AC? 4, 1. And I'd like everyone to call that point E when you graph it, please. So 4, 1. 1, 2, 3, 4. Yep, looks pretty darn good too, right in the middle of AC. 4, 1. All right, group 2. What do you got for point F?
8, 2.
8, 2. Call that point F for me, everybody, when you graph it. Looks pretty good. My end here, right in the, oh, that's 8, 1. 8, 2 looks even better. There we go. And hey, group 3, what do you got over there for midpoint of AB? 5, 4. Everyone call that point G. All right, good job, everyone. Good job. Don't connect them, please. They're just remember their midpoints. Okay, please remember their midpoints before we go on to the next task. All right, same group, same sides. But now I want you to find the slope of your side now. Okay, you guys have the same side you found the midpoint for, but now find the slope of that side. Hopefully this goes a little bit quicker than the midpoint. Find the slope of your side, please. Slope of your side. You don't have to fill in the next section. Just find the slope. That's all I need you to do. Find the slope of your side. Up and over how many? Rise over run. Change in Y over change in X. All right, what do you say? Group 1, slope of AC.
-2/3.
Yep, 4, 6, but I like it reduced to. I like that. -2/3. Got it. Group 2, slope of BC. 1/3?
3 over 1.
Yeah, 3 over 1. So 3. And group 3, how about the slope of AB?
1/4.
1/4. Good. All right. Here's what we're about to do and what I would like to do. We're going to start with side AC. We are about to graph a line together that goes through the midpoint of AC and is perpendicular to AC. Okay, so we're going to graph a line in a second, goes through point E, which is the what? Midpoint, but that line is going to form a right angle, be perpendicular with AC. So before we do that, if the slope of AC is -2/3, what's going to be the slope of this line we're about to graph that's going to be perpendicular?
3/2.
What's the relation? Are they the same? No, that's parallel. Negative reciprocals. Flip and change the sign, so it's going to be positive 3/2. So everyone start at point E right now. And if you know the slope's got to be 3/2, where can I go from E to graph another point? From point E, where do I go if the slope's got to be 3/2?
Up 3/2.
Up 3. 1, 2, 3. And now you said over, Brody. What's over mean?
To the right.
Right, because it's positive 2. If you want to graph a third point, go up 3/2 again. That's fine. Grab your straight edge. You need a straight edge here. It's not negotiable. I need a nice line here. Grab your straight edge and graph this line. Why is it not coming out thick? And please do not move on, because I want to talk about that line you just graphed. What do you know about this line? What did we just figure out about this line?
Perpendicular to
It's
AC.
perpendicular, and it goes through E, which is the...
Midpoint.
I would like you to take those two facts right now, that it's perpendicular to AC and goes through midpoint E, and give this line a vocabulary name, please, that we've talked about in the past.
Perpendicular bisector.
Perpendicular bisector, isn't it? Everyone agrees on that. That's perpendicular and it bisects AC. So this is a perpendicular bisector. Agreed? Okay, why don't we actually just put a little note right there. That is a perpendicular bisector. I want to do it to the other two sides too. Let's do this to side BC now. Do the perpendicular to the bisector for side BC. So if the slope of BC was 3, what's my perpendicular bisector going to have a slope of? -1/3. Here we go. So from point F, where do I go to get another point? The slope's got to be -1/3. So from point F, I go down 1. If I go left, though, it's going to start going like this, which would be positive. So I got to go down 1, right 3. Or if you wanted to go left, you could, but you have to go up 1, left for 3. Okay, up 1, left 3. Again, straight edge. What's that? That line you just drew, and that is a? Of BC, right. All right, we got one more to do before we come up with a conclusion here. So let's do it for side AB. AB had a slope of 1/4. So what's going to be the slope of its perpendicular line? -4. All right, good. -4. So where do I go from point G then? I need another point. So point G, I go a couple different ways, but just one way. Up 4. Okay, you want to go up? Up 1, 2, 3, 4, over. Left 1. Yep. Or down 4, right 1. Again, grab your straight edge. So what we just did, I know it took a while, but we just drew all 3 perpendicular bisectors that exist in a triangle. And what do we see about them? Using vocabulary already used today. All 3 perpendicular bisectors are what? Concurrent. Correct. They are all concurrent. So let's answer some questions now. Are these lines concurrent? You're darn right, but I'll just put yes. The conclusion? In any triangle here, in a triangle, doesn't have to just be that one, in any triangle, all 3, what did we just take so much time graphing? 3 what? All 3 perpendicular bisectors are concurrent. In any triangle you make up yourself, if you do the 3 perpendicular bisectors, it is guaranteed that they will be concurrent, meet at the same point. Guaranteed. Now the second half of this, all you know is that point's called the what? Point concurrency. But it has a new name when it's the perpendicular bisectors especially. All right, so that new name, I have it, yep. So if the perpendicular bisectors intersect, that point of concurrency we're going to start calling the circumcenter. That is when all 3 perpendicular bisectors intersect. That point will now be called, not point of concurrency, it will now be called the circumcenter. It is for perpendicular bisectors only, circumcenter. Questions? Craig, when I introduce a new point of concurrency, you have 2 jobs. 2. Know how it's formed. You already know that. How's the circumcenter formed? When all 3 what intersect? Okay, your second job is to know the special fact about it, which we're going to get to right now. Take your compass. I don't want to tell you the special fact. You're going to find out yourself. Take your compass right now. Put it on the point of concurrency or the circumcenter on your graph that we just did. Open it up so your pencil point is on one of the triangle's vertices. Everyone got it? So you should have your compass point on the circumcenter, pencil point on a vertice. Everyone good? Take it off your paper, but don't open or close your compass. Take it off your paper. Take it off. Put your compass point back on the circumcenter, but now put it on a new vertice. Did you have to open or close your compass? Should match right up, right? Same distance. Do it for the third point. Do it for the third vertice. Does everyone see? You didn't have, it's the same distance, isn't it? From here to B is the same distance as here to C, from the circumcenter to A. Same distance. So here's the fact you should know about a circumcenter. Circumcenter is equidistant from all 3 vertices. Equidistant from all 3 vertices. So on my diagram here, just so I can drive this point home, everyone draw a dashed line from O to A, from O to B, and from O to C. If O is the circumcenter, OA is congruent to, keep going for me. Name another line segment we just made from the circumcenter to the vertice. OB, same distance as OC. All right? So the circumcenter is the same distance away from all three vertices. How's it formed, by the way? The perpendicular bisectors form the circumcenter. And what's so special about the circumcenter? Equidistant from the vertices. All right, so let's try this out. I know you guys don't have this. I get it. You do have this, though, correct? Yep, great. That is also part of our downfall for some of us is the Promethean man.